Across the Fence, an invention for the farm. A UVM professor has come up with a device that solves a common problem on small farms. Good afternoon and thanks for joining us. I'm Judy Simpson. We've all heard that necessity is the mother of invention. Well, that's true, but you still have to have the skill and talent to do the inventing. Farmers are always trying to come up with a new way to solve challenging problems or develop something that makes the hard work of farming a little easier. Take humidity, for example. It's hardly a compelling topic, but it's a critical issue for many farmers. A few years back, a UVM extension professor developed a device to help small farms reliably measure humidity. That device is now being put into production right here in Vermont, saving farmers time and money. Across the Fence's Keith Silva has our story.
Welcome to the worldwide headquarters of Vermont Energy Control Systems.
The little guys are kind of our mission.
Bill Coons is an aerospace engineer. On his own, he started tinkering with a heating control system for his home about 5 years ago.
We started by figuring out how to control the heating system in our house in a better way.
Coons showed the system to his neighbor, Ralph Shepard.
Bill and I have been friends for about 20 years, and when I realized what he was doing with his controller that he developed for his own home, I felt that it had a lot more commercial potential. So with my urging and pestering, about 3 years into the process, we formed an LLC, came up with a name, and began to commercialize it and go to trade shows and renewable energy fairs and so forth to try to get some traction.
Vermont Energy Control Systems, VECS for short, specializes in monitoring and controlling temperatures for small buildings, spaces that can't be controlled by a thermostat.
It might be a church, a municipal building. We do some historic buildings, multi-unit apartment buildings. Anything that's too big to control the thermostat but not big enough to be able to afford a traditional, highly engineered building control system.
Coons and Shepard have developed a line of controllers they've named Vesta, after the Roman goddess of hearth and home. The controllers have to be accurate, so much so that if the temperature changes because, let's say, someone opens a door, Coons knows about it and can track it.
This is a mushroom farm in Philadelphia. They need their humidity to be very close to 100%, but not quite 100%. They don't want condensation. Moisture is bad. So what we can see right here, this is humidity, and you can see this line drop down a little bit here. What happened is they opened the door, let in a bunch of outside air. The temperature dropped a little bit, humidity dropped a lot. This red line says we had an alert. We sent them a message and said, hey, your humidity is low. And you can see the system respond and start opening valves and injecting water into their humidifiers to bring the humidity back up to where it's supposed to be. That's an example of us not only monitoring, but controlling and sending alerts when there's a problem.
As VECS grew, the agricultural community began to take notice. What they wanted to know is if VECS could solve a common problem with small-scale agriculture, monitoring humidity.
We had humidity sensors, but if you tried to use them in an environment that was 98% relative humidity all the time, they'll die. They just short out and stop working. So we didn't have a good solution. We couldn't provide the ability to do this to anyone who's working in a really high humidity environment. And that includes cheesemakers, mushroom farmers, anybody doing crop storage. There just wasn't a good sensor.
Coons and Shepard got a solution to the humidity problem when they met with UVM Extension's agricultural engineer, Chris Callahan. Callahan had been working on a device that modernizes what's known as a sling psychrometer, a time-consuming and cumbersome way to measure humidity. Callahan demonstrated this old-fashioned technology for Across the Fence in 2015.
And so as we're slinging this through the air, the wick on the wet bulb of the thermometer is evaporating moisture into the air. The wet bulb will generally be lower than the dry bulb, and it's that difference in temperature that lets us determine relative humidity.
What Callahan invented was an electronic, automated version of this manual device. It could be installed in a storage facility and monitored using a cell phone. The best part was, Callahan's prototype worked. Even at this early stage, Pete Johnson of Pete's Greens in Craftsbury was on board. He had once lost 40,000 pounds of potatoes due to a breakdown in his monitoring system. Johnson knew Callahan's device would be a game changer for small-scale farmers.
This is the kind of stuff where you go online, you check out what, big storage facilities, they have a certain kind of monitoring system, blah, 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 and you contact that company, and you're just not speaking the same language. It's a very different, they're dealing with, acres of storages where people are spending maybe $250,000 to set up the proper monitoring and all this kind of stuff, and it's very different to be able to call up somebody and say, hey, I want the second smallest model of what you have because it's perfect for me, and to call up with somebody and say, hey, I need something 10 times smaller than what you have, and that'll be perfect for me. And they're going to say, I have no idea what you're talking about. I don't know 10 times smaller. The UVM extension is super available. They speak our language. They know, you don't have to spend time trying to explain to them what you're trying to do. They get it, and then they go right to work figuring out how to make it happen. It's been indispensable, and it's helped create a new ag landscape in this state that really would have struggled to get going without having that backbone.
Callahan had built the proverbial better mousetrap.
So it was literally over Christmas break one year. I wired up something that I thought would be better based on a relatively tried and true approach to measuring humidity and just modernizing it a little bit. And so that really helped us get to a much better measurement of humidity. It's been a long way from that original breadboard prototype to what VECS has developed and is in the process of commercializing.
It's a great opportunity for us because it opens up a whole new market. We really like this one because it's a real problem. It really costs people money if they can't do this well, and there isn't a good solution. So it lets us go out and really work, especially with all the small farms that the farm-to-table movement is bringing into the marketplace. These guys need to do the same kind of crop storage, the same kind of monitoring, the same kind of control, the same kind of food safety that the big farms do. We have something we can offer to them to help them do that in a cost-effective way.
VECS has bought the rights to Callahan's prototype. It's being commercially developed with assistance from UVM Ventures and the Vermont Agency of Commerce and Community Development. Named the Do Right, the device sells for $300 and connects directly into VECS's Vesta controller. Callahan estimates an individual produce grower could see an annual savings of $6,500. Artisanal cheese and meat producers may see a savings up to $10,000.
The way I look at this relative to the land grant mission, if you will, and the mission of extension is this was a concept that turned into a physical prototype. And the challenge I had was, how do I commercialize this and make it more accessible and more available? That's not really that's not what extension is really best suited to. There are other companies in the community who are suited to commercializing something and being able to support it as a commercial product.
This collaboration with Callahan fits well with what Coons and Shepard set out to do when they started their company.
I'm not in it to make money. I mean, if we do make money, we're not going to be upset at all. I mean, that certainly is the objective. But I'm in it because it's causing me to grow. I'm learning things. I'm continuing to be challenged. When I retired, the thing I missed the most when I first retired was being confronted with unanticipated challenges that caused me to move outside my comfort zone and learn and grow. And we're able to do that with this. And one thing I would also mention is that we're a locally sourced company as well, that we've made every effort to procure our materials right here in Vermont. We use Vermont subcontractors for our sheet metal. Our goal here is to employ as many local firms as we can in the production of these products, which we're now successfully selling.
Vermont's a great place to do this. We have a whole supply chain of subcontractors and vendors who are all set up to do each of the different things, to make each of the different products that we have. And they're ready to go. So we've been getting ones and twos. If we need them 10 at a time, that's great. If we need them 100 at a time, we got suppliers that are ready to do it for us.
A humidity sensor invented by a UVM professor, made by a Vermont company that helps small farms in Vermont and elsewhere save money. That's what you call a do-right. In Moncton, I'm Keith Silva with Across the Fence.
Well, Chris Callahan joins me in the studio now. Thanks so much for coming in.
Thanks, Judy.
I'm betting this isn't your first invention.
I guess not. It's sort of been something I've kind of done my whole life. Whenever I look around and see something that's not quite where it could be or what it should be, I think about other ways of doing things.
So what's the difference between inventing something and then receiving a patent?
So invention happens all the time, and it's not always something that's patented. A patent specifically is intended to teach what you've invented in exchange for 20 years of exclusive rights to practice it. And so it is a decision to make when you invent something or come up with a new idea. Patenting is certainly one approach. There are others, and you know, open source venues for delivery of inventions, or keeping something as a trade secret, for example, is another way to protect.
What's your insight into why your design was able to withstand the humidity changes when other devices couldn't?
It was surprising to me that the other devices weren't more suitable to the environment that we were trying to use them in. And what it comes down to for me is they were really using they weren't actually determining the basis of humidity. They were using something that was an analog to humidity. And it depended on an electrical property of a material, and that material, when it gets wet, doesn't last. So, you know, it should be intuitive, but it wasn't. And so what we're doing differently is we're actually measuring the two factors that really go into calculating humidity.
And also, too, doing it on a smaller scale, because as we learned in that video, there are companies that do this, but on a much larger scale.
Right, and I actually think what we're doing is better than that as well. Regardless of scale, we have developed something that increases the precision and accuracy of the measurement in general.
Talk a little bit about UVM Ventures and the Vermont Agency of Commerce and Community Development and how they helped with this project.
Right, so UVM Ventures has been a critical partner in helping me navigate the patent pathway, commercialization pathway, exploring partners for commercialization, and then actually facilitating the agreements necessary to make this happen. The Agency of Commerce has been supportive financially with very early, some seed funding to explore the idea of patenting the device, doing some prototyping, and now supporting the co-development with VECS.
Tell me a little bit about what the reaction has been from farmers who maybe contact you and say, I have this problem, now what happens?
It's pretty significant and positive. Folks have been patient with the development of this. It's been an idea that I've been developing for 4 years now, and you know, folks have known about it, and this problem is near and dear to their hearts. These are products that have a lot of cost already embedded in them by the time they go into the storage room or the curing room, and so that process is really a very important step, and humidity is a really important part of that. So they're looking forward to it.
And you have other projects that you're working on now?
Plenty, yeah. So very involved in produce safety, and as it relates to the rollout of the Food Safety Modernization Act and how that's impacting Vermont farmers and farmers throughout the Northeast region. Working closely with the Agency of Agriculture, Food and Markets on that, and as well as our partner farms, and navigating that new landscape. Also working in the area of pre-cooling and curing. So we talked about storage of crops in the story. There's a step before storage, which is also really important. And the same project that led to this humidity sensor also helped enlighten me into the importance of pre-cooling product and also curing some storage products like potatoes, onions, garlic, squash, to extend their storage.
And what does that do for it? Just gives the farmers more of a crop to sell?
Yeah, it increases quality going into storage and also increases the longevity of the crops in storage and downstream going to market.
And the savings can be significant.
It can be significant. A number of the farms that I've worked with have pointed to savings we've been able to achieve in storage and post-harvest practices as enabling them to hire an additional full-time person through the winter, making it a 12-month position, and that's a significant impact to Vermont's economy.
Especially, too, when you're talking about some of the smaller farms.
Yeah, smaller and also diversified farms. So farms that are not growing a single crop or a single commodity, but growing many different commodities who need a little bit more nuanced control of conditions.
I want to thank you for coming on and talking about your invention.
My pleasure, Judy. Thank you.
Interesting, yeah. For more information about the ways that UVM Extension agricultural engineer is doing work that benefits Vermont and Vermonters, you can check out the website. It's right there on your screen, uvm.edu/extension, and click on the link to agriculture. That's our program for today. Thanks for joining us. I'm Judy Simpson. We'll see you again next time on Across the Fence.